Hello, everyone. Welcome to the very first episode of ScienceOverse expert panel. This is going to be a series of podcasts featuring esteemed industry experts from various scientific fields. And today I'm going to be the host of this conversation. And today's topic is the status of astronomy education in India. And I'm going to ask a series of questions to Avik sir. And don't worry, this is not going to be strictly restricted to the status of astronomy education in India. I will ask some very interesting questions too. And today we have with us Mr. Avik Dasgupta. He has specialized in astrophysics and spectroscopy, and he is currently working in science popularization. So without a further ado, let's start. Thank you, sir, for joining for today's session.
Thank you, Anirban.
So without a further ado, let's start our podcast. So my first question to sir would be, sir, please introduce yourself about your field of research and your educational background.
Right. So, good morning, all. I am Avik Dasgupta, and currently I am leading the Science Popularization Program at Center for Cosmology and Science Popularization. Before this, I was in charge of Astronomy Lab and at Vikram Sarabhai Community Science Center. My educational background is I did masters in physics with spectroscopy and astrophysics. And then I started working in science education, especially in astronomy education. And slowly, gradually, the idea is to take ahead the astronomy and science on a larger view, the grassroots, and in very simple language, apart from doing research. So, in terms of research interest, I like to make low cost curricula and low cost models so that we can explain astronomy, we can explain scientific concepts in hands-on activity manner. And in terms of hardcore research interest, I like to work on star formation, mainly related to fast star formation. So those are my interests, and limit myself to these things currently. Still looking forward to learn more and explore more.
Great, sir. Great to learn that. And you said you are working with science popularization with an institution, and you design low cost curriculum or things like that, right?
Yeah,
So,
yes.
any experience that is memorable to you about doing that sort of thing?
Yeah, so I think many, uh, but let me narrate to you one that what we did in astronomy education is while at Sarabhai Community Science Center, we built a very low cost model of a telescope called a box telescope, and that's a somewhat like $1 telescope. And almost till now, 2,500 or 3,000 students have made them themselves. So we would take these telescopes to their. These are paper-based telescopes and very low cost. And so we would take this to the rural kids, tribal kids, and they would make them on their own. And the idea is they take this telescope their home. So when I would see their faces that they got a new telescope and they have made it, so that sense of accomplishment and that sense of that they would learn something, see something, their own telescope. That probably pushes me to do more in science education and taking science to rural kids, making science accessible to everyone. So that is probably a memorable thing. And in one incident, like is last year or last to last year in one of these schools, we visited that school probably 3 months after that. And one of those students, uh, he said to me that, "Sir, I don't know how, but I will become an astronaut." So that is probably an accomplishment I consider to myself. I don't know about anything else. But, that student thing kept in, and probably I come from a very small town, so we know that is not accessible for everyone into fields like astronomy, and there are many misconceptions about how to start it, how one. So that is probably a memorable event, you can say.
Yeah, I share the same kind of experience. So I have a telescope, as you can see.
Yeah,
So
yeah, obviously.
I take this. I live in rural area, and I have taken this telescope to the outskirts of my village, to the fields, and their kids would usually gather around to see what I am observing. So the first time I showed them a view of Jupiter and its moons, its Galilean moons. It kind of
Right,
blew their mind. It was first for the first time. It was mind blowing for me also, and the first time
right,
I showed
right,
Jupiter and its four Galilean moons, kind of
right,
blew their minds too. So said this, they said we observe these things every day, like Jupiter appears like a star in the sky, but we never
right,
knew
right,
that this thing has so much details and these things. So yeah.
right. As you say, I remember my experience with Jupiter. So I started with a similar telescope like you have, and it was I was learning stellarium at that 10 years, and I got a small telescope, and around 2 a.m. in the morning, I saw this bright object, very bright object, and I was like, let's see what it is through the telescope. And then I saw through the telescope, and I saw that there are four more dots very close to it. So I thought of checking it with stellarium. And then to my surprise, that was the first object I'm seeing through a telescope. So that's Jupiter and the four moons. And I probably imagined at that point that what might Galileo have felt when he was seeing, and he didn't have anything. So it was like that eureka moment probably for mine. Because, yeah, astronomy always was that.
Yes, sir. So, sir, my next question is, you have specialized in spectroscopy and astrophysics, right, sir? So,
Yes.
sir, please enlighten our viewers what spectroscopy actually is, what are its scopes, and how is it used in astrophysics and astronomy?
Right. So, spectroscopy is the study of, in simple language, uh, every object which can emit, or every object through which light is passing is absorbing some amount of light, and which is emitting because of its constituency, absorbing some other thing of light. Now, if any given object which is emitting, star is emitting. So since it will have many chemicals, suppose many elements, suppose hydrogen, helium. So these lines will be missing from their spectrum. What is the spectrum? Now spectrum is if the light which is coming, that light is dispersed into its constant. That is in simple terms Vibgyor. Now in that Vibgyor, find some lines to be missing corresponding to some elements from the original light. Now, like we have Look, every star with some element composition or a cloud which is in front of something has some elemental composition will give different spectrum. And the study of this spectrum is called spectrum. So, in the beginning, sort of decade of 19th century or 20th century, so around 1900s, people used to study stars very rigorously and study their spectrum to understand what are the elements in the stars. For some advanced viewers of this stars, might note that stars are classified in E, A, F, G, K, M, N, and our sun is a G5 star. So that classification actually comes from what is the spectroscopic constituent star is. What the spectrum tells us. Okay, like our so I can tell two Indian contribution in this context. One is famous Meghnad Saha, who gave his Saha's ionization equation, which tells that by spectroscopy, observe the spectrum elements, then you can understand what is happening inside of the star. That is Saha's ionization. Not many people talk about this, but it is considered to be one of the revolutionizing equations of the 20th century, beginning of astronomy, even before Chandrasekhar's. The other contribution, which probably India again is the observation, even before the size line, is called observation of helium. So, the Madras Observatory actually observed that helium is present in sun. Helium was never found before that on Earth because it's a so we don't have helium here, right? So it was first observed in sun, and that is through spectrum. So spectroscopy tells us what are the elemental constituents of any black body object for advanced viewers, for easy viewers, for any object which is emitting light and probably absorbed by some different. So it may be a star, a cloud in front of a star, and this cloud have some, suppose lithium or bit of carbon. So when we observe this cloud, then we will see that imprint. Okay.
Uh,
Now,
so does it ever happen that the fingerprints of two different elements get merged and we don't know that what made this thing? Or every element has its own specific fingerprint?
no, no. Obviously, it happens. It happens. So if you so that is something called as resolution. Are you resolving the two lines? So like sodium has a doublet at 5.8. I'm not five around 5,000. So it has a doublet. So if you are not resolving, it will be seen as a single line. Resolving, then you sort of lines. Similarly, if you and that's why iron is used as a calibration element because iron has many lines across the spectrum. If we think of from 400 to 700, many lines across the calibrate a spectrum and you try to find other lines. So how would you find the, suppose you discover a new line, how would you know that what is the wavelength of this line? So what you do is you take a previously low line and iron is the element which generally is used, has so many lines across the whole visible spectrum. So that's why it is taken as a reference frame. and then you discuss. So obviously, if you see a real spectrum, so easier said than done. You see the real spectrum of sun, probably more than 1,000 lines you will see. So then you have to calibrate with some reference. If it's iron, then you try to identify which element. And obviously, there will be cases depending on how dissolution of all that two lines are separate, two are lines are separate, lying overlying, and then it is sort of analyzed. Fortunately, the initial days of spectroscopy in 1900s, there were several observations and there were several scientists working tremendously on these tools, purely observational. Their explanation from rotation and rotation vibration, quantum mechanics, and came very late. But observationally, they are very well sort of uh, analyzed and calibrated, and they are tabulated. So anyone interested can see White's book, which is every single line has been tabulated and very minutely people have studied this, and it is a cumbersome task. I cannot say enough that how cumbersome it may be, because for a known spectra you need to spend 6 hours, and cumbersome task, and they just really have contributed to our knowledge that which we take for granted that this is G5 star, our sun is a G5 star. How you classify the G, how you classify the 5, like everybody read about.
And then the movement of the star also shifts the spectrum towards blue or the red region. That
Yeah,
makes it.
I have not accounted for that. Okay, I have not accounted any redshift and blue shift and all those things going on. These are only laboratory, so you could take a sample of the element and probably you put in an iron arc, and then you take the spectrum of it, then you analyze, then you first you develop it, because at that time you have photographic plates. Even I have used photograph it, then analyze it, and then single, one line sort of identify. Very cumbersome. Very
Okay. So that, yeah, that really taught me something about spectroscopy. I always had this question that, yeah, these lines may get mixed up, then there is red shift, blue shift. It must be a
right.
very cumbersome process to, figure
Right.
out which elements are there. So,
So, so how do you identify? This was the earlier. Now what you have is have the spectral plot coming to you from, right. You have now generally after a telescope use prism. It's not prism anymore. It's grating and prism mixed something. And then you take the spectra and then you have a ready-made spectrum. Have the observe. But earlier, this shift and redshift, how do you identify? Is you there will be certain set of lines, right? So you have the iron line and calcium line. So this whole set will be shifted, right? To blue or to red will be shifted. And then you compare that. So how much that shift is will tell you how much blue shift or red shift. And then you calculate what is the velocity. And that is how probably Hubble studied. Because how we know a galaxy is blue shifted or red shifted? Where its spectrum could be new spectrum. analyze it.
Okay, sir. Moving on to our next question. So, as we all know that our solar system originated from a protoplanetary disk. So, a firm understanding of the protoplanetary disk is important to understand how our own solar system came about. So, considering the fact that you have worked on this field before, you have studied protoplanetary disks. So, can you enlighten us what you have learned so far, or what challenges this particular field faces as of now?
So there are many simple questions to which we would like to have answers, which will hold sense. One is how simple biotic and prebiotic molecules have come to Earth, and what are the chemical compositions which are present in sort of protoplanetary disk, because that composition will tell us what the planets are getting, and that composition will tell us what the asteroids and Kuiper belt objects they are getting. Because have in the protoplanetary disk the ordered variation of different elements as you go outside, because every molecule have will have some volatility. So as you go out, the temperature decreases and the volatile components sort of freeze up, and these are called ice disks. So that helps us to study what are the chemical components. So this is a burning question. Then we don't know many of the things like in exoplanet study. Mostly what we think, the bigger planets very close to the host star, which in our solar system it is not so. You have smaller planets very close, and then as you go out, you have the bigger planet, the Jupiter size. But when you see in exoplanets, you find something very different. So that is an open question. That is an open question. That why, how come you have smaller planets forming inside? So what is the migration? So how planets shift? And then you would like to understand another thing, that how planets form moon around as an exomoon problem, which in formation observation, I think there are only one observation. See that while planets are forming in the protoplanetary disk, are uh, moons, whether they are forming or not, whether there is. So that is also a point. So there are many open questions which probably scientists are dealing, and they are trying to find out answers to them. Is probably we would have more answers to them. We have already seen that protoplanetary disk exist after the advent of our, because we have now pretty pictures of those disks, the dust mid-plane, which we have picture. So, but there are many open questions and large audiences study about them, because we really don't know that how uh, many questions like how our Earth is so unique, we have how we have water on it, and the percentage of water. So all these questions are related to planetary disk.
Okay, so for our audience viewers, ALMA is Atacama Desert Large Millimeter Array. It's a radio telescope array used to study the protoplanetary disk. And yeah, I have one question about this. See, in our solar system, we see that all the gas giants are toward the outer, edges of the solar system.
Right,
Like first, in the inner circle, we have the all these rocky planets like Mercury, Venus, Earth, Mars, and then all
right,
the gas giants are beyond Mars. So is this a
right.
general trend that gaseous planets form outside towards outside of the disk?
So just as I said that what observation shows us that No, we have observed because there is also we have observed through Kepler, which is a transit phenomenon. So when the planet moves in front of the star, you see the dip, right? But so when you see that, you only get bigger planets. So till our observations are right now, we have only few observations where you see the smaller planets, sort of like our solar system. Maximum of the cases, bigger planets found, and has actually baffled scientists that whether or how the planet formation has occurred. So one of the theories which is we are considering is called a migration theory, that the bigger planets form first and they sort of migrate out towards the back, and then with the remaining elements, because at the beginning you have much of the, so that's why you have much gaseous planets forming, and then they move out, and now you are left with much of the dust and the debris, and then at the terrestrial. But again, this is again a theory which people are trying to know how science goes. You have theory, you have observation, and then you try to understand whether your theory is right or wrong based on that. So it's still an open question.
So, sir, you have worked with Spitzer data before, right?
Right,
So,
right.
what specialty does Spitzer telescope has as compared to other great telescopes that we have, like Kepler or Hubble Space Telescope?
So Spitzer is an infrared telescope, and you uh, so if you are on Earth, you can you not see many of the wavelengths coming through the atmosphere. So it's only the visible wavelength which are seen our eyes, and it's the radio wavelength far away, and you can use radio to. But infrared telescopes, because our water molecules are also very excited infrared lens, you cannot put a telescopes on Earth. Probably near infrared you can put, far infrared you can. So you need to put a space telescope and which can observe to have only. So one inherent property from that I can derive that where there is water, you can see through infrared. One thing. And infrared measures were a big thing um, back in the 90s. So you might have heard about laser. Okay. The first idea of laser came from water laser. Okay. That is microwave. So basically stimulated radiation, laser, the microwave version. So that came from water laser. And what people would like to do to observe that. That is one. The second thing is, if you have something of the order of temperature uh, 30 to 30 degrees Celsius, 30. So that something like our body temperature or less than that. So something where the temperature is very low, so you cannot see it in visible wavelengths. You have to see in infrared wavelengths. Second, and the third is if you have a dust around some object, like we discussed about the star, you have a dust around a newly formed star. Now, visible wavelength cannot penetrate through this dust, but infrared wavelengths, you still can see this dust emitting as a secondary. Okay, and some of the gas clouds can penetrate. So if you see Hubble, if you see Orion in visible wavelength, or if you see through eye, you'd see the main stars and gas clouds in it. But if you see through infrared, you will see the background stars. So you can penetrate through gas clouds, right? And you can see through them. So that is the benefit of infrared telescope over visible things. And Spitzer is one of the great observatories. And NASA has four great observatories. Spitzer is one of them. It's a very small telescope. It's 80 centimeter telescope. So probably 30 centimeter at mind it, in comparison, Hubble Space Telescope is 3.6 feet, but Spitzer is a very small telescope. And but now you have to liquid cool it because you have Earth, which is also emanating in infrared. So now what people did is there is something called Earth trailing orbit. So I would like everyone to go ahead and study the Spitzer orbit. It's very fascinating. So when it was launched, it sort of trailed Earth, and as soon as year passed, Earth moved ahead and Spitzer sort of went away from it. So it's called an Earth trailing orbit, and that's why it was shut down. I think 3-4 years back, so that what will happen in another 6-7 years, Earth will again come behind it. So again, Spitzer will be switched on, and again observation. So it's a very beautiful telescope in itself, and it has given us marvelous sort of observation about for infrared observation in sort of star formation regions, molecular clouds, galaxies which are far away. There is a huge archive which is sitting in Spitzer Heritage Archive, and anybody can access that data regarding the science what they want to do, and they can access this data. The Spitzer in my Spitzer was the first telescope probably of which I used the data of, and it still is a very useful telescope. And I would like to remind you one sort of result from Spitzer, for which Spitzer was not even built. So Spitzer discovered the TRAPPIST. Everybody knows the TRAPPIST exoplanet system. It's the 7 planets which are almost of the Earth size, right? It was discovered by Spitzer, and when Spitzer went into space, nobody were thinking of discovering exoplanets through Spitzer. So that's how efficient and reliable Spitzer is. And by the way, since we have talked about spectroscopy, it was named after Lyman Spitzer Jr., who was a huge figure in spectroscopy.
Is this the same person after whom the Lyman region of
He
atomic spectra?
he was I think he was the senior. He's if I'm not wrong, his father.
Okay. No,
So
we have Lyman
Lyman's
lines on hydrogen spectrum. So
exactly. So so Spitzer was a marvelous telescope in itself. Many people doesn't know, but many people know about Hubble Space Telescope. Spitzer is also a beautiful.
So you have said that NASA has 4 great observatories. One is Spitzer. I'm guessing the other 3 are Hubble, James Webb,
No.
and Chandra.
So there are 4 great observatories in the which were launched in 1990s. So Hubble Space Telescope, which Hubble is in visible, Spitzer is in infrared, then Chandra is in X-ray, and if I'm not wrong,
Compton.
Yeah, so these are the 4 great observatories of NASA.
Too bad they're decommissioning Chandra.
Yeah, so Compton is in Gamma. Compton is in Gamma. Then you have Chandra is in X-ray. Then you have visible. You have the Hubble, and then you have Spitzer. And now JWST is framed such that Hubble can also observe in near infrared. So it will correspond to somewhat more wave beyond what Spitzer can observe. So that's what JWST is the second generation. First
Okay.
generation where only this.
Yeah, too bad that they are decommissioning Chandra. It's like disheartening.
Yeah, but in space, you have to, there are much evolved missions which can go. You have to remember, even Hubble Space Telescope, which is giving so much of data, and Chandra and so these were built with 1990 electronics. So we are not using anything 1990 electronics right now. All these computers and mobile phones are post 1990. So what you have pre 1990 is giving out this type of image. The JWST is probably the newest, which is again 2000 2010 electronics, which is again we are not using. Okay, so space-based mission requires huge amount of time. So the electronics actually update during commission phase. So you need to super pass with a new absence.
So, moving on with the next set of questions. Uh, Coming back to our topic, what do you think about the current situation of astronomy education in India?
Right. So that's a very important question, and answer it way that see, astronomy education at higher levels is very good. It is considered to be contributing very actively in every field of research related to astronomy. But if you see the grassroots level where astronomy or astrophysics awareness or the outreach is concerned or the access to astronomy by particular. Last year we have there's a huge collaboration across India which we done, and we have worked on understanding what is the access of these students to telescopes or planetarium. So we have seen that only 1/7, that is 17%. Hello. Okay.
So
The
your
seven.
video pros. Okay, okay, now it's okay. Now it's okay. Yeah.
Now it's okay.
Yeah.
Okay. Only 17% of the students have ever accessed a telescope or a planetarium. So that's I would say, and that too, this survey was conducted in uh, resource rich and resource poor schools, mainly pertaining to good areas. So I would not say that we in this survey any tribal schools or very interior schools cover, right? Um, so that says a lot about the grassroots level of reach in also as anyone might understand who has gone through CBSE board education or state board education that you are introduced to some topics in astrophysics or astronomy per se. Like you are introduced to constellations, you are introduced to some planets, you are introduced something. But how it is related to everyday phenomena, how it is related, how you yourself can observe these. Like if you go to a class, if you go to a school, and that many a times you can try to ask them how to see planets, they would firstly tell that you need a telescope. But even before Galileo saw those planets, people had mapped the sky. So Galileo knew where to point at, right? So I asked this question that if you have a telescope, do you know where to point it? Because if you don't know, then a telescope is not of use. So the basic understanding that there are star maps, there are constellations, there is a yearly sort of uh, circular movement of the stars. You have the calendar because of that. You have the lunar calendar, and we have every festivals. India is a unique country in that sense because all the festival in India, in any religion, happens due to some or other lunar phase, right? But how many people, and especially students, know about how moon phases occur? Many people doesn't connect with the moon phases and the calendar which we have. So see, to live in our society, it is not only for education. In our society, if we are aware just how which day the festival is occurring, which day Holi is coming, which day Eid is coming, we need to understand astronomy. That's the probably the benefit of staying in India. But we have lost those understanding, and obviously this has been partnered with some weird prediction thing, and people are doing all these stuffs, but we have forgot the basis from where these calculations give us, from where our understanding started about simple concepts, simple Earth, Moon, and Sun system, that is a three-body system which is around us and which affects us mostly our day night. How uh, uh, like in India we have such a huge network of solar observatories. You have Jantar Mantar, right? How many people are aware that these Jantar Mantar are observatories? These are solar observatories. Very few, because you go to a school, you ask them, these are some magician things. So you see, we have everything around us, but people are not aware. People are not probably connecting with these, and then they are going uh, for weird sort of description of these events of the festivals and things like that, and then probably this leads to misconception and finally to many myths, unscientific myths. Like today also, in solar eclipse, you will not see many people coming, right? Many people not here. Okay. So it's very important. I would not say astronomy education is important for probably putting students into astronomy research first. Obviously, it should be the main goal, and there are many people coming out of India who are doing astronomy. But to basically understand our calendar, our own, you know, Hindi or Bengali or Gujarati, any calendar, which are based on lunar phases. Everything. So astronomy education, the condition is, I would say many, I have during my all these years in education, I have interacted with teachers. So the teachers are not trained enough to take it to the students because these are never there in the formal syllabus. Uh, People think that you always need a telescope to understand astronomy or to learn astronomy or to start with astronomy. But that is not the case. So you can start with simple star charts, simple. You don't need any telescope. So that awareness is not there. I think many of the at a primary level, at a secondary level, at a college level, even at a college level, I would say that that awareness is not there, right? So that is there. If we talk about higher, more on research perspective, to have all the big telescope and their data which are available. We are discussing the Spitzer data. Now, many students doesn't know that these are accessible and open to anyone. So these are all websites. There are archives which you can access that. And or probably there is a 1 and 1.5 year period after the observation. and after that, that is open to public. And nowadays, these NASA and European Space Agency, ESA, these are coming with some projects that are dedicated to analyze this archival data. So it should be, I think, more and more percolation of astronomy and to let the rural student understand that you have the best place to. Generally, the rural students have this concept that we don't have any resources, we don't have any things. So that is actually the best place. Have a light pollution free sky. You have the night sky. You can see the Milky Way. Still, our city people, we are not seeing any Milky Way. That is, I think, important in terms of Indian context and in a more general context of it.
Yeah, that's true because as I've discussed before that I have shown my telescope a view of Jupiter to village children, and
Right,
they kind of were oblivious of the fact that these Saturn, Jupiter, these things can be observed with naked eye also in a clear night sky. So when I
exactly.
showed them that, yeah, that's the bright thing over there, that's Jupiter, that's not a star. So
Right.
only then they could appreciate the fact that, yeah, we can actually observe this thing with our naked eyes. We just need the telescope to resolve some details, but yeah, these things can be observed.
Right,
So my
right. And
next, yeah, yeah.
that will just follow up that even the stars, you can understand the movement, daily movement. See the stars and you see them going up. So then actually you realize that there is a shift in the orbit. So you don't need any telescope.
Yeah, then there is the thing that every day you see the rising and setting time of this constellation shift by around 4 minutes
Four
every
minutes.
day.
4 minutes.
Like
Yes, yes,
uh,
yes.
that if today the Orion constellation rises at 12 a.m. suppose,
Right,
then
right.
tomorrow it will rise at around 11:56. So
Yes,
these
yes,
are some
yes.
interesting observations.
Yeah, another observation about moon that we talk about moon phases. You see everyday moon, it is shifting. You ask any student, they would say that moon rises from west and sun rises from east. This is again a misconception. That's what I'm referring to. The basic concepts, the very basic concepts for which you don't probably you need a 15-day period observation or a 1 month observation about stars and planets, and you don't need any tools. Many things can be learned out.
Yeah. So my next question is for people who want to get into the field of astrophysics or astronomy after they have completed their graduation, like someone like me who has done B.Tech in electrical engineering, and now I want to go to astrophysics in the field of astrophysics and astronomy. So, can you tell me the path that one needs to take to reach there, right from graduation?
Okay, so I think first and foremost is you are interested in astronomy. There, you start reading on yourself. There are many websites. So one is skyandtelescope.com, astronomy.com. These websites are uh, having daily sort of newsletter kind of thing, and they give you much detail. So start reading about it. You don't need particular to start. Then I would start from very basic. How can you associate yourself to astronomy projects? So how can you really contribute to astronomy, not only reading? So there is something called citizen science projects. There is something called Zooniverse. It's a website where you have many citizen science projects which are and freely register to them, and you can start working with actual astronomy projects. Okay, and then there are much dedicated citizen science projects like you have International Asteroid Search Collaboration, then you have radio RAD at home, which is an Indian citizen science project. So all these are there, and any student. So this is irrespective whether you are a school student, whether you are a college level student, whether you are post college student, whether you are employing person and you are doing some other occupation and still you want to pursue astronomy. So everybody is, and then comes the point where probably class 12 student. So one way is to take BSc, MSc Physics, then go to PhD in Astrophysics. MSc somewhere there are specialization in astrophysics, somewhere they are not, but PhD you can opt for more specific topic. Other ways, if you are an engineering student, you can go to astrophysics. Again, one benefit of engineering student is they can also go towards what is called astronomical instrument. For many people, we need big telescopes, and all these telescopes, you need understanding of astronomy also, and you need understanding of how instruments actually are built. So that is called astronomical instrumentation. Have this 30-meter telescope coming, where Indian engineers are working very hard for their basically the mirror alignment. So those are Indian engineers which are working. So this is one line which BTech, and obviously there is BTech and PhD in basic astrophysics or cosmology. So all these ways you can be associated with uh, astronomy or astrophysics. The other way, obviously, always is there is to associate yourself with some astronomy club. So search whether there is an astronomy club. There are many astronomy clubs in India. Abroad, there is something called Astronomers Without Borders, which is an international organization. So there are many ventures out there, and I would suggest every student search that what is available at his or her level. Obviously, there are this citizen science projects which is open to everyone study, but self-learning is the best. And at this juncture, especially when we are talking about free access to knowledge, have to be a self-learning at any point. You have there is GitHub, there are you programs, there are data available, there are archival program, everything is available. So you have to be a self.
Yeah, so one of the best applications that kind of got me started in basic astronomy. I'm an amateur astronomer. I always keep an eye on the sky for what to observe
Right.
today or what astronomical events are coming up. So one of the best applications that I have used so far is Stellarium. It is like
Yes, yes,
hands down one of the best. So it
obviously, and I there are many small ideas you can get from Stellarium. Stellarium, I also started uh, understanding the star maps using Stellarium. Stellarium has actually revolutionized, I would say, star maps. Earlier, we used to use sort of atlas maps. When I
yeah.
started, we used to use those atlas maps, 13-degree maps, and all these things. Stellarium has actually revolutionized. And there are many small projects. Uh, there is something called Stellarium Web for students
Yes.
who doesn't have a heavy machine, who wants to access from probably on your mobile. Have the app, you have Stellarium Web, which is a very lighter version of the whole app, and so that it makes easy, makes it, and you can understand a lot of things. You read about. So one exercise I can give to students. What you do is whenever you read about an astronomical objects, you go to Stellarium, search where it is in the sky, whether or not you can see it from northern hemisphere or not. Simple. Which constellation it lies, whether you can see it in the night sky, whether you can see it today, then you will have an understanding that how observational astrophysics. or where we can see what is southern constellation, what is northern constellation.
Yes. And for the viewers, Stellarium can also be downloaded on mobile phone, and it's a very good application to learn to schedule what you want to observe for the night and all that. You can just point your mobile towards the sky, and it would show you the astronomical objects that are present at that part of the sky, that portion of the sky. It's just a great application. So my next question to you is that what do you feel about the scientific temperament currently in India, in common people, the
Right,
attitude of people towards science?
right. See, scientific temperament is an issue which is probably a Nehruvian started way back in 1950. And I would say in India, we have a grassroots scientific temperament. There is some. good- I can give you an example. In During the COVID vaccine, we have a huge success of vaccination. In the polio vaccine, we have a huge success. That means people understand that vaccine helps us, and that means that these are good. So there is certain scientific which is uh, sort of pushed right from 1950s and 60s with all our 5-year plans and different sort of Krishi Darshan program. All these are basically all the scientific characteristics or the scientific temperament in an agrarian society. But I would also feel that uh, with the advent of computers, and especially in the last 5 and 10 years, with the advent of much fake information, this scientific temperament we are seeing that much of the time that sense. Because now what happens is you get uh, misinformation from authentic sources or from sources which you term to authentic, like media channels, many of them houses. So, but so we people will get this misinformation through some WhatsApp channels in social media. Now, these uh, would urge people to believe in this, and that would actually that is hampering the scientific temperament as a whole. So, no, like we have issues of conception and the solar eclipse people during discussing. People have many myths regarding lunar eclipse. Um, then again, myths and misconceptions are again they are linked some sort of religious practice. Then it is much more conceptions are much more sort of deep rooted. Then you are actually when you are trying to tell that this is a misinformation, then you are actually hurting his or her religion too. So we need to understand that part also, especially to understand that okay, this is the misinformation part, this is the religious belief part, and this is your own understanding and own thought. Misinformation is misinformation, has no backing, has no sort of evidences. And one thing I would like to highlight, this is very important to understand that through your channel, I would like to say that science is not a set of facts. Science is always evolving. So science is not that we say that 10 years back we had 9 planets. Now we have 8 planets. Does it mean that one planet has vanished or we were wrong? It is not like that. Science is always asking questions and understanding whether we are right or not. So, what at this point, when we are talking, is probably right. Probably at this point, there are 8 planets. And today evening, if that new definition comes in, which satisfactorily tells you that no, there are not 8 planets and there are probably 10 planets, then we have to accept it. It is not that science is not evolving, it is continuously evolving. So I think there is that temperament, I think students, people, college students, everybody have to understand. Science is not a very static thing, continuously evolving. What is true may be true in a smaller sense tomorrow, but on a larger sense, maybe it is wrong. So that openness in science is, I think, required, and that scientific temperament is also required in the grassroots level. So that should go to the grassroots villages. Okay, now there is some modern research, so now they are telling this. Earlier things get not right, the right.
Yes, so sometimes I see these kind of misinformation floating up in the mainstream media, and kind of saddens me how it's misguiding a lot of people. And have you heard of the Indian Flat Earth Society? I just came across the Indian Flat Earth
Right,
Society. I was like, guys, how could we stoop down to these levels?
right.
It's so disheartening. So
Yes, I think well, there are many topics like this, but I think that rise is again because uh, you sort of back these statements with certain modern computer-based simulations and all this. So there is something called computer-based astronomy. So you are using modern equipment to back up what is a long-term prediction. This is it, right? It cannot be true. So that has happened in the last probably 20, 10 years, that you have now misinformation backed by modern technological equipments. So that is probably a major discussion on science boon or bane, right? So uh, how these are technological advancements, these are given by science, but these are used to uh, sort of diminish the other scientific achievements, like you say, of flat earth societies. So if there are images available, there are people who are actual people, there are always 3 people or 4 people who are out in space, who are not on earth, they are revolving earth. So anybody can access ISS camera and see what is the light field is, and see what is the curvature of earth. So but again, that belief system is again a personal thing. You need to, that is the difference between science and belief system, right? Science tells you that you don't believe in it. You sort of ponder again and again and try to question it, try to poke it, try to understand it, try to observe it. Say what I we don't believe that there are 8 planets, right? We don't believe it. We understand it from scientific evidence. There is a difference between belief and evidence conclusion. So I think that part, if people understood, and I would refer you to one of the experiment by a flat Earth society. That
yeah,
what
I
he
have
did
heard
is
of.
he constructed some cardboard at a long distance. And his claim was, if Earth is flat, his claim was very scientific. If Earth is flat, you poke a hole at the same distance, then the light should pass through all the holes. From ground, if you poke the hole at the same distance, the light should pass. And he himself found out with 1 kilometer or 2 kilometers that the light is right. So because yeah, so so he himself, and then there's no belief. Then you have to take the evidence. Then you have to understand from the evidence in front of you. There is no belief. That is how science works. That is how discovery works.
The name of the guy is Enrique. I remember his name. And there was also one
Okay, okay.
experiment on. There was a very famous flat earther named Bob, and he kind of said that if the Earth is spinning, so it must do that at a rate of 15 degree per hour rate, which is true
Huh.
actually. So what he did, he raised funds to buy a ring laser gyroscope to measure the drift of the Earth. And what he did was he managed to collect all the funds, and he arranged for a ring laser gyroscope, which costed around $20,000. Huge.
Right.
It's a very huge expensive equipment. And
You
when he
see.
turned on the device and took a measurement for about 2 to 3 hours, and it turned out that yes, it shows a 15 degree per hour drift. So what he did with that observation, what he did with that observation, he said, see, there must be a cosmic energy that is interfering with the gyroscope. So what he did, he kind of again perform the experiment again inside of a Gaussian chamber. Like
Right, right,
no electromagnetic interference
right,
can
right,
affect the equipment, and it still showed
right,
15 degree per hour drift. And he just threw away the result. He said, "Oh, we don't believe in
right.
it."
That's the point. That he could have but to prove this, he could have just observed the stars. It would be much cheaper. It would be much cheaper. You didn't need anything. You see. So that's how I think misinformation in general occurs, and it also matters from whom the misinformation is coming. So if it comes from a person who is at a high pedestal, he then backs up the information. Then it obviously common people would take it as not a misinformation but science.
Yeah.
So it's a very fine line today. I would say much finer than probably what existed 50 years back. That what is science and what is misinformation and what is fake news. We are going through them. So I always tell students that you need to, if you see something in a video, you need to probably see 4 videos on that topic and every point. Read something on that point of view, and then come to your conclusion. Correct? Which is correct. So that is probably unbiased, forming an unbiased opinion.
Uh, Sir, since we are nearing the end of this conversation, this has already gone on for about an hour, I think. So I would bother you with one last question. Sir, have you heard of the news that Betelgeuse might go supernova within our lifetime? And I would like to have your views on that. And what do you think the view is going to be like from Earth if it goes supernova?
So obviously that's if it goes off in our lifetime, it will be once in a lifetime view in terms that probably last 1057 AD. After that, this will be brighter, almost brighter than any star in the night sky. And the but then again, during the COVID, what happened is the battle just dimmed a bit. And people thought that probably it is now going for a big explosion. Later, people carried out scanning of information and understood that there is Betelgeuse is going pushing its outer envelope phases. What happened during the COVID time is that certain amount of that gas came in front of our line of sight. It blocked certain starlight from the petal. One view is that the other sort of understanding is that probably disk, like our Kuiper belt, some disk of metal line so that we are seeing less. So as and as more and more people are getting observation, uh, understanding that probably not in our lifetime, but that is another 400, 500 years. In terms of star, it is very small number of years. In terms of humans, it is much more than 5, 6 generations. So probably we will not see all. But again, we really these are again open questions, and that's what I would urge students that there are many open questions in astronomy which needs answer and needs your participation in astrophysics. The universe is vast, and the questions are much more than the universe size. So there are many questions which are unanswered, like this: oh, when we will see it, what are the actual things we will see? Whether we see it, like there are many planetary nebulae, there are phases, whether it's bright, such bright that in 1057 supernova went off. It was seen in day as a star, Venus star. So whether we will see that. So these only time will tell. But probably it is nearing. This is nearing. I hope that we see that once in a lifetime event. But I will assure you that we will not be affected by any of these plumes, or because many students have this question whether we will go off. It is very, very far, of the order of I think 300, 400. So we will not have any. Probably we will have visible identification of this star going bright, much bright, few days.
Yeah,
That
I heard that if Betelgeuse does go supernova in our lifetime, it would be so bright that it would illuminate our night sky just like a full moon does. And it's hard to imagine that a star can be so bright. So, yeah.
I think there is who will not go to full moon because in magnitude scale it is minus 13. Probably somewhere in between that. It will be bright, obviously, it will, but these are a bit speculative. So only time will tell. I will leave it on that.
Yes.
Like whether it will be full moon or half moon, only time will.
Yeah, only time will tell. And hopefully,
Yeah.
I think we won't be around to witness this if it happens within 400 to
Hopefully,
300.
because
Yes.
no, that's the thing that we really don't know how. No, this part of the thing is called core collapse. Core collapse of a supernova. What will happen at that point? We really don't know how fast it may trigger or how fast it may not trigger. But obviously, from a scientific standpoint, I would say this that if it goes off in our lifetime or in the next 100 years, we now have instruments so that we can understand about this whole thing. Next time we can probably say that, okay, This we know when it will go through and when it will be much bigger, much brighter.
Okay. So we have at last come to the end of the conversation. It was a very enlightening conversation. Thank you to Avik sir. Thank you for taking out some time from your busy schedule to do this. And for the viewers, I would like to say that please follow us, follow ScienceOverse on Instagram, and like, share, subscribe to this channel. Uh, you will see the details popping up in the screen over here somewhere. And this is going to be a series of podcasts with many experts. It's the first installment of that series. And once again, I would like to thank Avik sir for being with us for today.
I think
Thank
thank
you,
you,
sir.
Anirban. Thank you for calling us in, and it was great pleasure talking with you and discussing all the things. Hope students learn something out of it, and it was excellent. Thank you.
Thank you, sir.